Mukund, thank you so much for joining me today.
Super excited to be here. Thanks, Pratik.
Let's start with the state of play for vibe coding products. And obviously, vibe coding took off big time. A lot of people are building applications, they're building software. So, where is the world today in terms of vibe coding platforms available?
Right. So, vibe coding, it got started like when this LLM models came out. And the whole concept is that you just talk to an agent or an application just like you would talk to a developer, and it sort of goes and builds the software for you, and you never look at the code, you just look at the output, you do white checks, and that's how the term sort of got coined. And we are building for non-technical users, so non-developers. I think we are today in sort of GPT-2 GPT-3 era of vibe coding, I would say. Right. And I think we're at an inflection point where you'll see suddenly a lot of these apps today, like, are building prototype, building MVPs. But over the next, 6 months, 9 months, you'll start seeing a flurry of these apps running in production and truly getting a lot of usage, and a lot of people sort of building their dream apps and getting them monetized. So the way I view it is that, we are just in the beginning innings of this today. And I think vibe coding will just become coding, like, very soon, and most of the people would just vibe code. And to us, it feels like, GPT-3 era of things, and we are probably a couple of model upgrades away from like a really extreme vertical takeoff.
Yeah, I think that transition is going to be amazing, where vibe coding is just coding, because at one point assembly language coders were real coders and everything else was, but now we don't do that. I think that the definition keeps shifting and abstractions keep going up and more people come into the ecosystem. So maybe we can start with, in plain English, what is Emergent's offering? Basically, a new user comes to you. What does the product?
Yeah, so we allow anybody on the planet without any coding knowledge to come to the platform and just describe what they want in natural language. They can talk to the platform, or they can just type and describe what they want, a web app, a website, or a mobile app. And sort of the platform sort of goes ahead and builds it out for them. And they get like a full stack production ready app that they can actually launch and monetize and get usage on. And essentially what happens behind the scene is we have this very sophisticated coding agent that works autonomously behind the scene to put together everything that your app needs, whether it's a backend or a front end or database or integrations. And what you get is a real usable app, and that's the gap in the market that we're trying to fill. Where, instead of just getting a prototype, a UI prototype, you actually get a full production-ready real app, which is secure, which has data privacy, everything built in. So you can actually go and launch this product and have usage on that.
Amazing. Let's go back to the first initial few days. So you saw a gap, you have this idea, you launched a company. So walk us through the first 90 days from prototype to traction. Like, what were the maybe 2 or 3 decisions that unlocked this huge adoption that you're seeing?
Yeah, so our journey has been a bit longer, and we sort of launched 3.5 months back, but we have been working in stealth for like last 8 months, and before we launched the product. And when we sort of started off, we actually were initially building testing agents which could actually go and test your mobile app, web app for enterprise. And then we slowly realized that like the problems that we were solving were very general enough that we could actually build a general coding agent. So we started building general coding agent, and there's a benchmark called SweetBench, which is essentially where all the coding agents are benchmarked. We became world number one on that multiple times, and sort of like that allowed us to like really spend our time to think through the problem really well in terms of what would it take for a non-developer to sort of go from an idea to an actual usable app in production. And those sort of 6-8 months sort of really allowed us to be sort of deep in research mode, really figure out how agents work, what would it take to build world's best coding agent, and then build the entire infra around it to sort of support the app building process. Sort of our realization was that to really get a production ready real usage app, what you would need to do is embed all of the best engineering practices within the platform, right? So our platform acts like just the world's best engineering team encoded in within the platform and agents, and that sort of takes you to a production grade app. So we were in stealth for a long time, build this out, and obviously like we were seeing this huge influx of demand from people on these platforms. And we started testing our app building platform, and just saw that it was working better than most other platforms. So we decided to launch in June this year, and since then I've been sort of just growing like crazy. And over the last 3.5 months, like we've grown to almost 2 million users now on the platform. More almost 2.5 million apps built, and a lot of these apps are going into production, are getting monetized. And the first sort of 90 days of launch, we were really focused on getting the message out to the user, and we wanted to go as broad as possible, get as many users as possible. And what we saw that eventually the product was working really well, that we started getting a lot of users on the platform, and they started referring each other. Every time an app sort of goes live, it attracts more users to the platform, and that's been the journey so far.
Amazing. And if you look at the model or the tooling stack, the infra, if you had done the same things in 2023, right, 2 years ago, would this be possible? Or rather, like, what got unlocked in the last 24 months that now you can do this with trust and reliability, and it just looks great, it's smooth, it works? So what changed in the last 24 months?
I mean, obviously, model capabilities have improved. Like, I think Sonnet 3.5 was like an inflection point in sort of agentic, possibilities. The the hardest problem that we were trying to solve was, how do you get a model to give you a JSON output? And we had built systems around it. 3.5 Sonnet came out, like 99% of the time the model will just give you what you ask for, right? So I think obviously the model capability increase is sort of which is leading to this big inflection point where now models can actually almost match human level coding expertise and can work for hours long duration without any human assistance. And I think what was also important is that you have these model capabilities, but how do you sort of harness them? How do you sort of build the right infrastructure around it, build the right architecture around it that maximizes what you can get out of these models? And essentially we built out this whole multi-agent architecture where different sub-agents would come in and do specialized work. For example, we have a testing agent which will come test your app. We have a design agent which will come and design your app for you. And so we built out this whole architecture. We also figured out how do we sort of variably give more compute to a harder problem. So when we see an app that sort of or let's say a complex bug, like we are able to sort of dynamically scale up compute on those problems. Then we built out the whole memory layer, which allows models or the agents to sort of remember what they have done in the past and not repeat those mistakes, do better. So I think one vector is obviously intelligence going up, and the second vector is essentially how do you harness them to their best potential. And building out this whole infra, which is sort of optimized for app building, truly allows us to extract the most out of these models today.
That's amazing. And when you build infra like this, and obviously you can spend forever building the most perfect thing, but in startups, velocity is everything. So what infra bets did you make early that has shaped your velocity? And when I say infra bets, I mean models and context management, memories, evals. Like what bets did you make that allowed you to move so fast?
So I mean, there were a few early things that we did, which are paying off really well for us right now. Like one, I think we just spent a lot of time understanding the models, right? So we spent a bunch of time just reading through the traces of every single model output, and building a really strong intuition of like where the models are good at, what models are good at where, and what models are not that great at different things. And today, like if I read a trace, I can tell you like, hey, Claude is not behaving as expected, right? So I mean, so we build this intuition, and that really sort of allows us to sort of peek into the future a little bit, saying that, oh, which model capabilities should we solve for today versus which should we not solve for today. So that was like at base level set the right foundation for us. Second thing, we took sort of an asymmetric bet where in order to move fast, most people were sort of relying on third parties to, like let's say Superbase to provide the database, like an E2B for their running their code. And we had this notion that the agents are going to be as good as the feedback loops that you will give them, right? So if it can't actually look at an error, if it can't look into your database, it's not going to be able to solve the problems, because invariably, like, it'll make mistakes. But the good thing is that can it actually like improve on the mistakes? Can it solve the mistakes? So we took this approach of building everything in house, completely the entire stack. So we built everything on native Kubernetes, so that we are able to scale them, keep them cost efficient, but in the end provide agents with the same dev environment that a regular developer gets. And so everything is packaged, the backend authentication, front-end databases, everything is packaged within the local machine. And that allows for like a really, really superior app building experience, because agents can now, like just like a regular developer, look into a database, figure out an error and solve for it. And we had this like very strong belief that that I mean, we need to control every single piece of the infrastructure to sort of really, one, iterate really fast, and second, to be able to close all of these feedback loop, and that has paid out really well for us. The other big bet that we took was to sort of platformize the hard parts. So, for example, authentication, payments, bunch of these things where it's very common and you need to keep them secure. We sort of built out almost like a first party infra for those, supporting multi-tenancy, supporting authentication, bunch of those things on the platform. And largely, a third thing was essentially like spending a lot of time on the agent quality, which is where we sort of invented the whole multi-agent architecture, solve for the memory bits, and not just the short-term memory, but also long-term memory. So our agents actually learn across multiple apps. Every time an app is getting built on the platform, they're able to sort of understand and learn from those mistakes and make them better. And also on the compute side, like one of the core theses that there are 2-3 core theses that we have internally. One of them being compute solves all the problems. So like, how do we sort of leverage more and more compute in an efficient manner is something that we focus a lot on. And secondly, we focus a lot on is giving agency to the LLMs, right? So we think that we are betting big that LLM's capability will continue to increase exponentially. Right? So we want to make sure that all of the agency is with the LLM and they get to decide what's the next step. And that sort of keeps us in the right direction of LLM sort of capabilities growing on the platform.
Right. And when you think about app building, many times the common, not complaint, but people say, hey, if you describe everything well initially, one shot, and then what comes out is great. But after that, debugging, like it takes a hammer approach versus like a surgical precision where I just need to change one element and then you describe something, the whole thing changes. So how do you shape your product on giving enough control to the user, but at the same time making sure like you're not making them write detailed code? Like how do you think about that product decision?
Yeah, so I think it's one of the hardest problems to solve today, right? Like where precision edits, and the way sort of we have structured things. I think it's a misnomer that if you give like a very good prompt up front, like things are going to be better. It's actually much better to sort of build it incrementally, like so start with a smaller thing and then sort of build it out. And so what we have done internally is a few things. One is that we are very test heavy. So every time the agent writes the code, it's also going to write the test. So, like every time you ask it to make a small edit, it's going to rerun all of those tests to make sure that the previous functionality is not breaking. It's not perfect, but it works in practice much better than, other platforms do. And the second thing that we are also now sort of incorporating into the product already is providing allowing users to give a lot more feedback. So for example, when you say, hey, my login is not working, we automatically extract all the logs and the session data from what user has done on the platform, and pass that to the agent so that it has all the context to solve the problem. And that really helps us narrow down the problems. The other thing we have done is essentially like figure out how do we scale up compute for tricky bugs. So whenever we see like a doom loop, like for example, a thing is not getting solved even after multiple chat, we'll then sort of fan out a lot more compute and sort of fan out different models and try to isolate the problem. And that sort of really helps us solve some of these problems today. It's not perfect, but I think it's improving every day.
And when you think about taking an app to production, one click to production, it sounds amazing. As a user, I love it, but I'm sure there's a bunch of like hard infra stuff you have to do to make it look nice and awesome. So what are these like unglamorous parts, infra parts that you had to do to make it, hey, let's go to production?
Yeah, it's been a journey. When we started, we like supported only one kind of app. So you could only build a fast API, Mongo, and React app. And we had built the whole pipeline to automatically sort of, package your code and take it to production and run security checks on top of it. And what we discovered, like the variety of requests that we get is fairly large, and people would install a different library that we didn't expect. People would, use a different sort of infrastructure. For example, they'll put a Redis or something in the middle. So what we have now done is what we call agentic deployment, where essentially because we have this lineage of your build process, right? So like what all steps the agent has taken, we sort of monitor that and extract out of that infrastructure as a code, right? So basically now, we convert all of that process into infrastructure as a code, and then deploy this into production. So your app is scalable, your app is secure. And no matter like what the build process looks like, we're able to extract that and get it to the production. It's still, again, not 100% perfect, but we're getting very close to, almost taking any kind of app and making sure that it runs in production in scale in a secure manner.
Right. Amazing. Now, Going into the architecture of going from prompt, plant, code, test, deploy, keep it running, what are the points of failure here for somebody as a user who's like, you don't expect anything from the user because they shouldn't have to worry about infra? So for you, what are the points of failure?
Yeah, I mean, I think every single step has its own failure points.
Hmm.
Like the question is, how do you recover? I mean, it's general software engineering principle. Like, people spend almost 40-50% of their time debugging and testing, right? I mean, if you look at like a general software engineering as well, they spend like, and this is something that we are educating our user also about, that typical software process involves 20% design, 30% coding, and the rest 50% is essentially testing and debugging. So I think there are various failure points. For example, like getting the requirement right, like, like from a user is hard. In fact, like, we don't think the prompt or the text is the right way to start. We are sort of experimenting with multiple different modalities on how do we take the input from a user. I mean, second obviously is the build phase, where, like, is your app getting built in the correct way? Is it maintainable? Does it scale well? I think all of those points of failure sort of come in. And then obviously, testing and deployment are sort of big failure points. But I think what is important is, like, one is your agent able to understand the feedback and then sort of, self correct on it. And that's the sort of the power of agents, that they can actually look into the database, they can actually look into the logs, figure out, okay, what is going wrong, and then sort of self correct. And it's an iterative build process. Like, so you'll
Yeah.
describe it in one way, and then you'll change your idea as you're going along. I would want this to be in a different color, or I would want this also to be there. And how do we handle that? That becomes really important.
Let's go into models and reasoning capabilities. Obviously, you've experimented like a whole lot with what's available across all the offerings so that you can build and shape your product. So which models handle planning versus code gen versus tests and commit messages? Like how do
Right.
you divide the work? Like what's the division of labor? And also what was the decision making process behind?
Yeah, so we experimented a lot with, all sort of models, including open source, including fine tuning our own models. And today, what sort of, what we use today in production, we have this fine tuned custom router which figures out which request to route to which model, depending on the complexity of the request, depending on the state of the app and everything. And we use a mixture of all the models today, and that's one of the reasons that, like, the application layer has an advantage today, that they can actually pick the best model for the best job, and sort of build for that. For example, we use Gemini for a lot of the multimodal stuff, or wherever longer context is required. For example, when your context length gets really big, we use Gemini to sort of compact the context. And then we use OpenAI's GPT-5 in thinking mode for a lot of the debugging and planning. And typically what we do is we will generate multiple plans and then have a verifier, custom fine-tuned verifier model that will figure out what is the best plan that we want to execute, because planning is one of the most complex things, and a lot of these things happen behind the scenes, so user doesn't sort of get to know about the complexity. And obviously the workhorse is the Claude, so most of the code is written by Claude and Sonnet 4.5. And then we have a mixture of our own fine-tuned models on Quen, and to take care of like simple steps, for example, looking into a log file and for example, parsing like a large file and extracting the right information. And increasingly, what we are seeing is that, like, as model capabilities are improving, like these models are sort of getting more rounded. So you'll probably in future be able to sort of, like, pick and choose one of these models to work.
And when it comes to reasoning, maybe a two-part question then. Like, just if you had to explain reasoning to a new user who's not into AI. So how do you think about reasoning capability? And also internally for your product, how do you assess reasoning capabilities of these models so that you can choose one versus the other?
Yeah, I think reasoning, the way I would describe it, is essentially, to take sort of observation and facts and sort of, like, hypothesis, and then figure out the right hypothesis for that, right? And typically, for example, let's say there's a bug, right? And your agents would sort of hypothesize that, okay, bug could be because a variable is missing in a code, or it could be because you're calling a wrong function somewhere. So generally, like, how do we sort of generate hypothesis and then let agents sort of validate them? And usually this is the chain of thought reasoning, where the model will internally think of a hypothesis, reason through it through some logical deductions, and then either discard it or pick that to sort of test it. And that's where the whole concept of test time compute is very effective, where the more compute you're able to spend during the reasoning phase, the better answers you would get in the end. And so we essentially, the way we do it today is we largely index on the end output, right? So we don't sort of measure the reasoning parts of things that much. We sort of index very heavily on the end output of the whole app building journey, and see what the quality is, and sort of parameterize along those lines. And I think the model capabilities of reasoning are sort of improving exponentially, and that's what we have been observing. And what has worked really well for us is again using this mixture of model approach, where we are able to use multiple models for different operations. For example, GPT-5 could spit out a plan, but then Claude can verify it, and things like that.
Let's talk about context management, memory management, knowledge. So many things you may have to do, like RAG over repos, and docs, and how to make plans, long context models. So what's your view on context engineering? Like, how do you do it internally for the product?
Yeah, context engineering is super important. Like one of the most important things that you need to get right to build extremely reliable agents, and especially because our agents sort of run over 10,000, 20,000, 50,000 steps deep, right? So context engineering becomes really critical for us. So I mean, we actually started by using RAGs initially, but now we have sort of given up on RAGs. We think, especially for the coding space, they don't work really well. And what works really well is again what we internally call an agentic search. So essentially, an agent sort of goes and looks through files just like a human would, a little file, you leave a function and go to that function and then explore. And this explore and exploit sort of thing in an agentic way is what we have seen works really well. And of course, as the code base gets bigger, we'll introduce RAG as well. But that's sort of what's been working really well for us right now. And in terms of context, like the way we do extremely active context management. So I mean, one sort of principle that we have is, one, we let the context grow as long as it can grow, so that everything is in context for agents. But as soon as we see limits getting reached, we sort of actively prune out the bad context. So there's a parallel sort of LLM thread that runs almost like an outside observer of the process, and figures out, okay, which context needs to be taken out, which context needs to be inserted back in. There are a bunch of tricks that we do under the hood to make sure that the context is actually very pristine, and we run some of the micro evals on these things. I think we're probably one of the best products in terms of context engineering today.
Amazing. Yeah, I think that's context engineering, it's becoming more and more important. And I think as more people use it, they expect a lot from these products, and which means that you better have your context well engineered. And I think that the agentic search part is actually a very important one. How, when you look at a large code base, how do you represent a large code base so that agents hallucinate structure? Is pretty basic, and as a user, they're like, "Hey, it's all here. Why are you making stuff up?" So how do you do this?
Yeah, I mean, today it's done. I mean, there are a few ways that we sort of do things, but again, largely we fall back to basics. I mean, our sort of general principle is, what would a human developer do in this stage, right? And can we sort of get the agent to do the same thing? And again, human developer has tools. For example, if you're working on an editor, VS Code or something, you can actually just click on a function, go to its definition, click on a function, and see all of its usage and things like that. So we have provided agents the same exploration capability of the code base, so they can actually instead of reading a bunch of files, it can actually explore through the code. And then there are some agent friendly stuff. For example, how do you explore using abstract syntax tree, AST. And then we also have LSP, which is essentially language server protocol, which essentially are all of the non LLM or static ways of exploring and finding the structure in the context of the code. That really helps agents actually explore the code really well. And a lot of our focus has been on building these really good general purpose tools for agents, which is customized for our use case, but general enough that it can be applied on any software engineering task. And we spend a lot of time in just making sure that these tools are really high quality and works really well. And in general, the principle that we sort of keep is, okay, what would a human developer, smart developer do at this point, right? And can we sort of get close to that? And then we start thinking about, because LLMs or agents have a different property. For example, they can look at multiple files at the same time, right? How do you sort of use that to your advantage? For example, how do we do parallel tool calling to get multiple things in the context at the same time? It's still evolving as a process. We are learning along the way, but so far I think keeping things simple has been good for us.
To move into orchestration, basically, you have multiple agents. You need them to talk to each other and not run into clashes. And it's just a fascinating topic. So, as a starting point, let's say I have an app. It's running. It's working well. And now I want to add like a simple thing, like, hey, add single sign-on, right? So once I type that, can you just walk through like what happens? I describe that I want to do this, and then like what does what tools are invoked, what does the agent do, and how does the work get done?
Right. So, the moment you describe a new thing to new sort of instruction to an agent, we first figure out, we have a classifier that runs that figures out what kind of request it is. Is it a complex request? Is it a simple request? Is it a bug? Is it a feature? And basis that, we sort of trigger different sort of a custom agent to sort of take care of your request. And so suppose single sign-on is a feature that you would want to do. We'll probably say, okay, it's a complex feature request, right, as a classification. And for example, let's say you say, hey, I want a single sign-on and I want my database to be bagged in a bunch of things. So we sort of break it down into micro instructions first, and then we start executing those instructions. The second thing is happening is the code exploration. So we have, agent will either re-explore the code if it already has the context, then probably can skip that part. To just build the context of the code, like what is happening so far in the code base, and then we sort of fan out into a planning phase. It will actually start planning how to execute this feature for you, and generally then we would sort of come back with a plan and validate with the user, saying that, hey, this is what I'm going to build, and does that make sense? Because what we have seen sometimes is that users, because especially we are working with people with no coding background, right? Like their description of things might be very different than what a technical user would describe. So we take this confirmation step, and then like we figure out, okay, what are the testing step for this, and then the agent sort of goes ahead and builds it, tests it autonomously on its own, all the basic tests, and then it'll pass back the control to the user to sort of test again and take more feedback. And the way it works is it's a lot more iterative. So just like you would talk to a developer, so you will tell a developer saying, hey, build this. They'll come back with a working product, and then you look at it and say, oh, okay, this is not working, or this is something different that I want. And that iteration, the process is where most of the software gets built.
Amazing. And when you have multiple agents working, how do agents coordinate? Like in simple terms, like how is that done internally?
Yeah, it's complex. I mean, because we have experimented with a lot of, we have our internal agent to agent communication protocols, and we have experimented with a bunch of protocols where agents can communicate in natural language, where or agents can communicate in a structured language, or they would, agent one will write a file, agent two will read that file. And so we have experimented with a bunch of things. And for different sub agents, we use different protocols. For example, let's say if it's a simple request, for example, you're requesting a document, library document, right? Then it's a search query. It happens in natural language. If it's a testing request, we generally give a more structured output. There is no sort of like common recipe right now, but sort of through experimentation, we have figured out what works in which context, and sort of are working on that. But there is a need to sort of unify all of these protocols, and to sort of make it more standard. So far, I think the most common thing that works is essentially writing into a file, right? So you write into the file, let the agent read the file. But there are some new clever ways that we have discovered, and maybe we'll share the next time. Yeah.
And when you look at how agent runs, how it does a piece of work, how do you debug an agent's chain of thought? Like what happens?
Yeah, I think it's one of the hardest problems today, right? Like, how do you sort of really, especially because there is one non-determinism in LLM. So if you run the same thing again, twice, thrice, you'll get a different output, right? And second thing is essentially that these traces generate like a lot of data, right? So I mean, you'll have like millions of tokens, sometimes like 100 million token within a run, and then sort of debugging gets very difficult. We have built a lot of internal tools that we first looked outside, try to find if there's somebody solving this problem. We couldn't find anybody who was solving this problem for these long-running agents, and for complex outputs. So we have internally built a lot of tools to sort of analyze the traces of agents, figure out like what are the like tool errors, and also like how do we do sort of micro A/B tests. So we let the agent run till a point and then swap the tools and see whether it performed differently. So a lot of this is sort of like we have spent a lot of time in instrumentation and analysis tool that we have built internally to monitor and constantly improve the agents. And this is a combination of micro evals, combination of some of the A/B tests that we run in production to figure out like, okay, what's going to work, what's not going to work, and very, very hard problem to solve today.
Move into this company building and you as a founder, as a leader. So this is not your first rodeo. Obviously, you built a company before. Dunzo, very well known in India. Obviously, it's hugely popular. So now, what best practices are like? What are you bringing into Emergent, and also what's something that you are doing differently this time?
I mean, there are a lot of things a lot of the learnings that just carries forward from Dunzo days. Primary being like just like insane amount of focus on users, right? I think when we built Dunzo, like it sort of became one of the most loved consumer brands in the country. Became a verb, and largely because like we were maniacally focused on like, hey, what does the user want, and we'll do everything to make sure that the user reaches the result that they want. And I think the same kind of focus and user sort of obsession is sort of what drives us every day today at Emergent. And I think the other thing that sort of like, and again, some of these like are in hindsight, but one of the other things that we are very focused in Emergent is solving like really the hard problems, right? And because I think that's where most of the alpha is today, like like you solving a hard problem. I mean, whether it's building our entire infrastructure ground up, even though it took us a little bit of time, even though it's fairly complex to manage those infra today. And also like going very deep into like how to build like really world class agents, how do we solve hard problems of like memory and agent to agent communication. So I think we really take a lot of pride in like one, identifying, okay, what is a hard problem that we can move the needle on, and then sort of really going really aggressive on that problem and trying to solve that problem, because that's where we think that will move the needle for us. And for example, right now like we're very focused on improving the code quality, because what's happening on the app on the platform is that apps are getting bigger and bigger and bigger. Like I mean typically like typical app size today on the platform would be like a 35,000 to 50,000 line of code. And on top end we have like 200,000 line of code, 300,000 line of code apps. And just to give you context, Emergent's entire code base is 100,000 line of code. So now we're like really focused on like, okay, the game has sort of shifted to can you get something functioning to can you get something that will actually work as you add more and more features on it. So we're very focused on that as a hard problem right now, and especially in the context of non-technical users. So how do you sort of solve for them? So I think these are the sort of core principles that around which we are built. We are also like betting really heavy in the direction of AI progress. So like every time we discuss something, like we try to imagine, okay, what would the models do in 6 months, right? And do we need to sort of really solve for that right now, or let just model catch up on some of these capabilities today? And the third thing is I think just like bringing in people who are obsessed about problem solving and like are really top of their field, right? So most of our team is top IIT rankers, Olympiad winners, repeat founders, and so so the talent density is extremely dense today at Emergent, and that's really helps us crack some of the hard problems today.
Amazing. Yeah, I think the view on there's like a thread or a discussion earlier where, hey, you can use the foundation models for stuff, but keep the decision making to yourself, versus the architecture is like, hey, offload the decision making to the model, because that's going to move way faster than what you or your team can do, because it's just the entire world is like pushing it forward. So even though some people think control is lost, but net you'll still gain, because you have to ride with the model. Like the model is getting really good, really fast. So you'll miss the boat if you want to kind of hold on to just for pride to hold on to the decision making. So I think that's a great point. All right. With that, we're at the rapid fire round. I'll ask a series of questions and would love to hear your answers in 15 seconds or less. You ready?
Yeah, let's go for it.
All right. Question number 1. What's your favorite book?
I don't read that many books, but I would say Hard Things About Hard Things is probably one of my favorite.
Which historical figure do you admire the most, and why?
I think Steve Jobs, as much as we call him a historical figure. I mean, I just growing up heard his speech and then saw his presentations. It had a really deep impact on me in terms of like how one person can change the world so much, right? In terms of bringing the best product out, and so It's been true inspiration for me.
Right. What's the one thing about infra that most people don't get?
I think infra is very, very hard to build, but once you build it, it gives you so much leverage that, like it almost becomes like a mode that is hard to compete against. And good infra takes a lot of dedicated effort to build.
Next question. What separates great AI products from the merely good ones?
I mean, I would say attention to details and truly understanding where your customer is and meeting them there. And for example, like maybe models is not capable to do X, so how do you sort of bridge that gap? And also, I think just solving the hard problems for those models. Yeah.
What have you changed your mind on recently?
I mean, I have sort of reaffirmed my faith in like most of the alpha isn't just building a great product. Like, if you just continuously, and I think the great product compounds. So I think that's something that I've sort of flipped my mind before and then flipped again. Yes.
What's your wildest AI prediction for the next 12 months?
Okay. I have made a lot of wild predictions, and often AI has actually, like superseded those predictions. I would say one, you would have, co-worker level, companions very soon. Like I think over the next 12 months. I also think like everybody will have a digital twin. So, most likely you and I will be doing this podcast. Our AIs would be doing podcast and then do this didn't work. I would say those two. And third probably is that one of the application layer would sort of break through, companies would break through and compete with foundation models.
That's interesting. That would be very interesting because it's usually been the other way where infra companies, foundation model companies, they're like taking over apps and killing apps. So I'm hoping like the pressure should also come from the other side. All right. Final question. What's your number one advice to founders who are starting out today?
I mean, I would say that like, I feel today like every idea is $1 trillion idea. And I think I was talking to a friend the other day and he's very passionate about toys. And I was telling him that, hey, if you build a great AI toy, like the next generation would trust that AI more and like you'll be the default AI. So I think even though it seems very competitive, it just feels to me that every single position is open. We are so early right now that I would just, like go all in and pick the problems that you really, really like want to solve and love solving and just go hard at it today.
Amazing. Mukund, this has been a brilliant discussion. Loved your insights, loved your hard-earned knowledge. And also personally for me, very exciting to talk to the founder of Dunzo because obviously it's a very, very familiar name. As you said, it's a verb almost. So thank you so much for coming on to the pod and sharing your insights.
Yeah, thank you so much for the.
All right.